Okay, hello and welcome to this video where we're going to be looking at reciprocal graphs. This obviously comes under the general topic of graphs, which you've been looking at. You've come across linear graphs, quadratic graphs, cubic graphs, and reciprocal graphs are part of the A-level course and you need to know about them. Reciprocal graphs are quite interesting in the fact that they sort of have like a break in the middle of them. Okay, so there are areas of the graph which don't really exist for certain values of x and y. Okay, and it's really important that you understand that. So when we are asked to sketch a reciprocal graph, it's really important to find out where are these discontinuities. Discontinuities basically means areas where the graph does not continue. And once we found out those regions, we can then build or write, the equations of the asymptotes. Okay, asymptotes are obviously lines which represent x and y regions which the curve does not sort of exist in. We should also try and ensure that if the curve crosses or touches the x-axis, that should be labeled. And as you should remember from previous lessons, finding x and y intercepts are quite straightforward as long as you can set x equals 0 to get your y-intercept and y equals 0 to get your x-intercept. Okay, so what are the two types of reciprocal graphs that you could find? Well, there's the normal type, which either looks like a over x or where a is greater than 0, so a positive reciprocal, which has this sort of shape, or a negative reciprocal where it's a over x again, but a is less than 0, and it has this shape. So there's a normal type of reciprocal graph, and we look at A and B examples here. And then there's reciprocals with the x squared in the denominator. Okay, and that looks slightly different. So where does this graph come from? Why does the reciprocal graph look like this? In fact, it's quite easy for you to generate this yourself. If you were to, if I gave you y equals 1 over x, and then I asked you, can you plot that between 0 and 7 inclusive, you just be substituting those values in. And what you'll notice is as the x value increases, the overall value of y decreases. Okay, so as the x value increases, the y value decreases. However, the opposite is also true. If the x value decreases towards 0, the y value increases as well, because 1 divided by values that are getting smaller come out with a greater output value. There is a sort of similar relationship here as you go into the negative x-axis. As you go into the negative x-axis, the larger the negative value, the smaller the overall negative y value will be. Okay, and as you get closer to 0, the larger that negative y value will become. Okay, right. So a over x, if a is positive, greater than 0, it will have this shape. If a is negative, then it will have this shape. Okay, and that sort of highlights a reflection from here to there. Okay, so if you look at these graphs, if I asked you to find out a transformation between them, you'd say to me it'll be a reflection in the x-axis. Okay, which you'll look at in transformations video down the line. So what we've got here are a couple of simple sketches. We've got sketch y equals 2 over x and y equals 4 minus 4 over x. Now, if you look at the general shape of a reciprocal graph, it looks like this. At A level, there is no necessity for you to be very, very detailed in your approach to the reciprocal graphs. A sketch gets the most important features that we need. Okay, so 1 over x will have this sort of shape. 2 over x, what you'll notice is if you were to put in values into 2 over x, the graph will come out slightly away from where 1 over x is because the values are higher. Okay. However, you don't need to sort of show that comparison on this graph. You can just do a very simple sketch like this. Okay. So I'm using my tablet. So okay, so that is a decent sketch of y equals 2 over x. Do not forget that you have to put the asymptotes in. So the x-axis is represented by the equation y equals 0, so that's an asymptote here, and the y-axis is represented by the asymptote x equals 0. Okay, so those are the asymptotes for y equals 2 over x. Now we've got y equals minus 4 over x. Again, the general, when you have a negative value on top of your x, the general shape will look like this. And we don't need to sort of be very, very concerned with the steepness of the gradients or etc. We just need to get the general shape correct. Okay, so as long as I can, emulate that, I will be fine. So, and I'm using my trusted tab here. Okay. I've got to be very careful. One thing that you've got to try and get accurate is to show that there is no intersection with the x-axis. Okay, it's got to try and show that. A bit better. Could be slightly smoothed out there a little bit. Okay, again, the asymptotes, again, it should be fairly symmetrical as well around there. So I'm going to try and improve on this. So these are little things that you can try and do to ensure the accuracy of your sketch. And again, we need to have the asymptotes. So the y-axis is here. Sorry. The y-axis is here. And it's given by the label x equals 0. And the x-axis is here. It's given by the label y equals 0. Okay, now we've got these sketches complete. One thing it's quite interesting for students to answer is why does the graph not exist around these values? So why does it not exist around x equals 0? So if you were to try and do that in a calculator, you would if you're trying to put x equals 0, that the calculator would not work. The calculator would not essentially give you a value. You can look into that in a lot more research. You can find out the reasons why, and you'll go into a bit of a discovery as to the nature of maths and numbers. Similarly, if I've got y equals 0, there is no x value for which gives that value. So 2 over x equals 0. If you were to try and solve that, it doesn't really work. There's no x value which divides by 2 to give you 0. So that's why these asymptotes exist. So that is the simple reciprocal graphs. And obviously you can go onto desmos.co.uk and you can do all sorts of things on there and replicate these as well. There are some practice questions which basically do the same thing as I've just done, which are worth having a look at.